So guys, we got into the inaugural NASA TechRise competition. NASA will pick the top 57 teams that submit proposals and give them a flight to test their experiment. And 38 of those teams are going to space on a suborbital rocket. You heard us right, Astral Orbit is going to space. Nearly 600 proposals were submitted for the competition, and only 57 were picked.
Our team wrote 3 proposals, one on polymerized adhesives and microgravity.
Specifically, we wanted to see how well cyanoacrylate, commonly referred to as superglue, would bond together and how strong the bond would be. Our second proposal was flight computers and microgravity. This would test how well chips, sensors, as well as common construction techniques would hold up in the very demanding conditions of a suborbital flight. And as for our third proposal, which was actually selected, we're going to be testing lunar regolith. Lunar regolith is essentially moon dust. These little particles are problematic. They're very tiny, they're very sharp, they kind of float around on the surface, and they're electrostatic. And as to why this is important.
For each of our 3 proposals, we looked into certain ways that our experiment could have greater implications in both the research and scientific communities. When we went to the moon on the Apollo missions, we experienced major troubles regarding lunar regolith. Our rover's wheels got shredded. Anything that had a moving joint essentially was toast. So if we plan to go back to the moon and stay there and make habitations there
for weeks, months, and years at a time, we need a much better solution to understanding lunar regolith. And that's where our experiment will come in. We're studying 2 major aspects of regolith, both its cohesion, which means how well it sticks to itself, as well as its adhesion, which means how well it sticks to other things. Now, we're going to be studying 4 major other things that it could stick to. We're looking at studying a plastic, namely PEEK, which is a very high temperature and high strength 3D printed material. We're looking to study aluminum, obviously a very common spaceflight material, as well as carbon fiber, which is very common in composites, as well as orthofabric, which is essentially the main material used on outer skins of spacesuits.
How we plan to do this is by having a chamber with 4 different plates for the regolith to stick to. So the rocket we're flying aboard is the Up Aerospace Space Loft, and that is basically a very, very, very large model rocket that goes to space and back. So in order to keep it stable, it uses a technique called spin stabilization. So the fins are purposely tilted slightly so that way the rocket spins very, very fast. We're going to use this in our experiment. So on ascent, what's going to happen is the regolith will slam into the plates because the whole chamber is going to be rotating because the whole rocket's rotating. And then when it reaches apogee, it'll be in space, and then the rocket does a de-spin maneuver, so it stops spinning very quickly, and that will cause the regolith to come off. So then we'll test how it sticks to itself.
Now, in addition to this main payload to test regolith, we're also flying a secondary payload. We thought that some of the research on our flight computer's payload was so useful to a lot of the amateur rocketry community that we wanted to include at least a part of it. We want to see just how well these sensors work on these very demanding flight profiles and see if amateurs can reliably use these sensors in their own rockets. So, we're going to be running a small breakout board that hosts many different sensors, specifically IMUs, which are inertial measurement units, which can find acceleration and orientation, as well as barometers, which can find air pressure and use that to find how high they are.
And what we would be testing with that, they aren't tested in high stress conditions or edge case conditions such as that of space. So we were trying to broaden the knowledge available and help amateur spaceflight enthusiasts better choose their hardware and equipment.
And for all this, we have a pretty tight timeline. Our experiment has to be shipped in June, which means we have to move very, very quickly. And we're going to be looking forward to a flight in early 2023. In addition, we're looking to take you guys along for the ride.
Today we're announcing that we're starting a new video series. I don't know how often these videos will come out because they're based off of how fast we reach deadlines, and we want to be focused on the deadlines for the actual project and not for video stuff. Point being, we're going to be uploading videos explaining what we've learned from designing this experiment. We will also be doing the same thing for TARC and other smaller projects we do from here on out.
Subscribe to Astral Orbit. I dare you. I double dare you. I triple dare you.